Hi, welcome to our focus on science. And just like with the last unit, here in Unit 3 with our focus on science, we'll start with language, then we'll look at culture, and then we'll move on to what are the strategies that just kind of tumble out of those concerns about language and culture. And also, what is any research that's been done around science practices for English language learners? What does that tell us? Okay, but today our focus is on language. And so in a nutshell, what I'm going to do is to share with you what do we know so far about what really challenges English language learners around the language of science. And for this lecture, there's a handout. You don't necessarily have to have it printed out, but if you could refer to it as I'm giving the lecture, I'll assume that you can see these sentences and examples. Okay, so the first thing that I want to share with you is that science is very unique in one way for English language learners, and that is that there are more new vocabulary items on every page of a science textbook than in any other kind of academic textbook that they encounter throughout their school day, all the way from kindergarten through graduate work. And so just that right there makes us realize that there is an additional challenge for English language learners when they walk into a science class, whether that's biology, physics, whatever it is, chemistry. They're going to encounter more new vocabulary than they encounter anywhere else. And so if you are teaching science and you have any language learners at all in your classroom, it absolutely, of course, needs to be a part of your planning to think about how to respond to all of those new vocabulary items and how to support your students with strategies to learn them. Even for someone like me, a native speaker of English, taking science classes, especially in high school and college, was really challenging. And so I can only imagine had I been doing it in my second language. So that's the first thing I want to make sure that you realize is that vocabulary is always big across the discipline. It's huge in science. The second thing that I wanted to talk about is I wanted to talk about something that we talked about with math, and that is that there are a lot of vocabulary words that come up in science that students will walk into your class already knowing as BICS vocabulary, basic interpersonal communication skills, everyday vocabulary. And on the handout that you have waiting for you in your unit, I gave just a few examples just off the top of my head. For example, the word mass. Many students, especially if they have a religious background, they would have experienced someone saying it happened after Mass, talking about Mass as kind of a religious term. Matter, they will have heard that a lot, being asked, what's the matter? Gas, don't forget to stop and get gas, or of course, the other meaning of gas when you have a stomach problem. State, we live in Washington State, so they would have already have encountered the word state either as they were learning how to identify themselves or perhaps in their social studies class. Cycle, he cycled over after practice. And apply sunscreen every day. So those are just a few off the top of my head. And so for those of you studying science right now, you just finished up with math and you saw that that was a problem as well. Between science and math, this is a bigger problem in math than it is in science, but we still see it in science as well. The second thing that I want to focus on with you around the difficulties of the language of science is around the fact that when words are defined, when those new vocabulary items that students encounter in science are defined, it's my word, it's kind of like a rat's nest with other vocabulary. So in other words, if a student encounters a word that they don't know, and even if the textbook has a glossary, on the side of the page or at the bottom of the page or at the end of the chapter, wherever it is, when they go to that glossary to find out what the word means, they're going to encounter very likely a problem. And that is that the vocabulary word is actually defined with other new vocabulary words. So you end up with kind of this endless rat's nest of vocabulary that the students can't pull apart. And they're probably going to need your assistance with that. So some examples that I give you on your handout, for example, producer. If a student doesn't know what the word producer means, they look up the definition. What do they find? An organism that makes its own food using energy from the sun through a process called photosynthesis. Examples include flowers, trees, and plants. So if they don't know the word producer, it's very possible they also don't know the word organism, energy, process, or photosynthesis. So you see where this is going. And so this is, I think, another example of where we think of a glossary as a built-in tool, a built-in assistance for students. But if you're an English language learner, those things that are laid out there as possible tools may not be that for you. And just for fun, if you look at the definition of photosynthesis, so if you say to yourself, okay, what if I didn't know what photosynthesis was? Well, let's see what that definition tells us. Photosynthesis, a process by which plants and some other organisms use light energy to convert water and carbon dioxide into oxygen and high energy carbohydrates such as sugars and starches. I think you get what I'm talking about there. And so what do we have so far? Students are going to encounter lots of vocabulary they don't know. Some of those vocabulary will have an extra dimension of difficulty because they already have a BICS meaning, an everyday meaning assigned. And then for the ways that these new vocabulary are defined in science textbooks, they're often defined in terms of other words that the students also don't know. So just there, we've got a lot of issues around vocabulary, okay? So the next thing that I want to talk to you about is around grammar. And I'm going to spend a little bit of time on this because I know for many of you, grammar is a real struggle. You're still trying to wrap your mind around how English grammar works and how you might explain it to others. So we'll take our time with this. So there are several different ways that grammar is quite difficult in science writing. And when you're listening to scientists too, because we tend to, in the disciplines, talk very similarly to the way that we write. So the first thing, and I have it on the handout there for you, the first thing that I want you to notice is there are a lot of adjective clauses that are used in science writing. So what's an adjective clause? Well, let's start with the word clause. Clause means it has a subject and a verb, okay? So it has a subject and a verb. Adjective means it's a subject and a verb that's describing something, okay? So the example I have for you on the handout is that makes its own food. And a lot of adjective clauses, not all, but a lot of adjective clauses begin with the word that. So let's look at the whole sentence. A producer is an organism that makes its own food using energy from the sun through a process called photosynthesis. Okay, so what we have there is we have a noun, organism, and then right after it we have a clause, right? That makes, that is the subject, makes is the verb, and it's actually describing the noun before it. And in fact, that's how I teach my students to be able to notice adjective clauses and to be able to notice in their own writing whether or not they're complete. If they see, for example, a noun, and then right after it there's something describing the noun that begins with that or which, that's really a good indication that what you have is an adjective clause. So no big deal, right? I mean, adjective clauses help us, give us more information. Well, it's challenging grammar. It makes for very complex sentences. And if you have beginners, they're not going to know what to do with that extra subject, extra verb sitting in the middle of the sentence, and they're probably not going to make the connection that that set of words is actually giving them more information about the noun before. So adjective clauses are throughout science writing, and they do provide more information, but they also provide an extra challenge for English language learners. Now, it gets even more fun. Are you ready? So, you can actually, and you know this because you do it, but you may not realize that you know it, you can actually reduce adjective clauses. So for example, let's go to the one that we just looked at, that makes its own food. You can drop out that and makes, add an ing, and let's look at that sentence. A producer is an organism making its own food. Okay, so we took out that, we changed the verb to an ing, and that becomes a reduced adjective clause. Why is it reduced? We've left out part of it. What did we leave out? The subject of the clause. So why am I talking to you about this? Well, because we do it in science a lot. And here's an example, so take a look. A producer is an organism that makes its own food using energy from the sun. And so using energy from the sun is a reduced adjective clause. So again, if a student is struggling with English and they know that every sentence has a subject and a verb, and they find those, and then they see these extra verbs floating around, they may not even be able to understand the basic idea of the sentence because they get lost in these additional clauses that are there. There are also very complex noun phrases. So what's a phrase? So a clause is a subject and a verb. What's a phrase? A phrase is a group of words that belong together. And so for example, if I say house, that is a noun. If I say a house, that's actually a noun phrase. Those two words go together and they're acting like a noun, but it's more than one word, so we use the word phrase. So if I say a black house, that is a noun phrase. A pretty black house, that is still a noun phrase. So no matter how many adjectives I add, it's still a noun phrase. So one thing that happens in science is we often create really complex noun phrases. Here's an example I found for you. A kidney transplant patient's donor. A kidney transplant patient's donor. So if you look at the way that those words relate to each other, a kidney transplant, right, that's a thing, and then it's describing patient, and then the donor to that patient. So there's a lot going on in what ends up being just the subject or the object of a sentence. So one thing that you'll really want to notice before you put any type of science writing in front of your students, or before you have them listening to any science talks, for example, is to have an eye out for those really complex noun phrases. And we'll get to the strategies, but just off the top of my head, one of the things that I would do with such things is I might even put them up on the board and do a little pre-teaching before the students encounter that, so they can even just basically decode them. That's pretty difficult. Another thing that we see in science that happens more in science than any other discipline, I think, are what are called nominalizations. And that's a really fancy way of saying to take a verb and turn it into a noun. Okay, so to take a verb and to turn it into a noun. How do we turn it into a noun? Usually by adding a suffix. A suffix is a little ending that you put on the end of a word. So what are some examples I've got for you? Distribution, explanation, conclusion, destabilization, analysis, indication, right? So notice that analysis doesn't follow the ION pattern. So there's other ways that you can form those nouns from verbs. And you might be thinking, so what's the big deal? If a student, and I know this from my own Spanish, if a student has learned a verb, doing the mental gymnastics that it takes to think about that verb as a noun, even though we automatically do it, it's pretty challenging. And so every time an English language learner encounters one of these verbs that have been turned into a noun, they've got to stop and do a little bit of mental gymnastics to make that happen. So that's another aspect of grammar that can be a real challenge for students. And the last aspect of grammar that I want to talk about is around passive voice. And passive voice, I know some of you are still struggling with what that means. Passive voice is when the subject of a sentence is not the thing that's doing the doing. And I know that sounds crazy, but all these years of teaching, that's how I've said it to students. So the subject of the sentence is not doing the doing. The subject of the sentence is having something acted upon them, right? Like if I say the door was closed. Did the door do the closing? No, it didn't. So that's not an active sentence. If the subject of the sentence did not do the doing, I know that sounds crazy. If the subject of the sentence did not do the doing, it's a passive sentence, okay? The man closed the door. Did the man do the doing? Yes, he did. So that's an active sentence. The door was closed. That is a passive sentence. So why am I bringing this up? Because science writing traditionally is full of passive sentences. What are some examples? Let's look at some examples and let's talk about why science writing might have so many. So here's an example of passive voice. Insulin was first discovered in 1921 by researchers at the University of Toronto. And I've underlined was discovered. So, so you can see there that who did the doing? Researchers at the University of Toronto. But they're not the subject of the sentence, and they're included in what we call a by phrase. So why in the world would science go to all of the trouble of writing a sentence that could have easily been an active sentence in passive? So the active version would have been, researchers at the University of Toronto first discovered insulin in 1921. So that's the active version of the sentence. Well, there's a couple of reasons. Often in science, what we're doing is we're emphasizing what was found, or we're emphasizing what was discovered, what was created, what was stated, that kind of thing. And so the emphasis is on the object of the sentence, not the subject. And sometimes we're even de-emphasizing who did something. Sometimes, for example, these researchers at the University of Toronto, maybe there were hundreds. Maybe not one of them ended up becoming well known for this particular discovery. So it's kind of a way to move the subject of the sentence off to the side. I hope that makes sense. So, and that's a great example of a sentence that's been written in passive to do just that. Let's look at the next one. The sodium hydroxide was dissolved in water. This is the type of sentence that a student would write in a lab report in which they're describing what they did in an experiment. The sodium hydroxide was dissolved in water. So if I were the one who wrote that sentence, who dissolved the sodium hydroxide in the water? I did. But instead of saying, I did this, I did that, next I did this, science is usually written in the passive voice, just what happened. So when you're taking yourself out of it, that means that you're moving that object of the sentence up to the subject of the sentence, and then the verb needs to become passive. Here's another example. This solution was then titrated with hydrochloric acid. Same thing. Someone describing a lab experiment, and they've taken themselves out, so it doesn't say I or we titrated the solution with hydrochloric acid. They've taken themselves out, and what happens is you move the object of the sentence up to the subject. This solution was then titrated. Another example, an experimental solar power plant will be built in the Australian desert. Will be built. So one thing you can see there, it doesn't have to be just passive or past tense, right? Was discovered, that's passive past. But we can also have passive future, will be built, right? Will be built. So lots of different options there for passive voice. Over the years, sometimes students have told me that they were told by a composition teacher, never, ever, ever write in passive voice. And I think one of the problems with that is that you cut yourself off from a really kind of key tool you can keep in your writing or your speaking toolkit. Because in disciplines like science, for example, where you're trying to emphasize what was discovered or what was acted on rather than who did it, if you take passive voice out, then you can't do that. We see passive voice all the time, despite what your 7th grade composition teacher said. We see passive voice all the time in newspaper writing, for example. So often when a crime is reported on in the newspaper, it's reported on before we know who did the crime. And so what happens is we just read what happened to the victim. The victim's house was broken into, the victim's car's tires were slashed, were broken into. The woman was scared by the robber's gun, that sort of thing. And so I don't want anything that you've been told about the passive voice and how awful it is to get in the way of you noticing that your English language learners are going to encounter it in science. It's not a bad thing. It's the way the writing works, and you need to make sure that they can decode it. They can understand how it works. So those are the basic points that I wanted to make about grammar. And there's another point that's very much related, and this has to do with how we form plurals. So let's say that you are teaching a science class, whether that's in 3rd grade or 8th grade, and you have some high beginning English language learners in your class, and they haven't mastered a lot with English, but one thing they've mastered is that when you have a plural word, you add an S. So they know that bit of morphology. And then they encounter science. You put a reading in front of them, and suddenly even how the plurals are formed changes. Why is that? Because science is the language of Latin, and Latin makes the plural in a different way. So on the handout that's waiting for you in the module, just for fun, I've given you all the different ways that students might encounter the plural being made besides an S in science writing. Sometimes it's an AE, an INA, an ICES, sometimes with an ES, which will not be that difficult for them. Sometimes with an A, sometimes with an I. So it's just all over the place. So even something as simple as forming a plural can be really challenging for your English language learners in science writing. So, woo! Boy, that's a lot, don't you think? Okay. So the last thing that I want to share with you around the language of science, and what I want you to be noticing as you're heading out into taking a look at the readings we're going to do and looking at the reading that goes with your discussion, is I want you to recognize that often The language that is put in front of students with science is what's called context reduced or decontextualized. So, for those of you who were in second language acquisition in the fall in ESLG 480, one of the things that we looked at is we looked at BICS and CALP, that everyday language and that academic language. And so we were looking at Jim Cummins' research. And then another thing we looked at is what makes CALP so difficult? Why is it so difficult? And one of the things that Jim Cummins found was that we often, when we present students with academic vocabulary, with academic language, we're presenting it in a way that's decontextualized. What does that mean? What that means here is that if we, for example, are telling our students how to do a lab experiment, as they're listening to us, if the only thing we're doing is just we got our hands at our sides and we're just talking, then if the students can't understand our oral words, there is nothing else they can hold on to make meaning. So context reduced means there's no lifeline, right? There's no lifeboat, there's nothing. If you don't understand the words coming at you or the words on the text, you've got nothing else. So contextualized means students have other ways of making meaning. So let's go back to an instructor introducing a lab experiment to students, telling them what they're going to do that day. If the instructor has some of the words written down on the board and has all of the tools in front of him or her that the student will use, then as the instructor is saying, well, the first thing I want you to do is I want you to use your beaker. And so they grab the beaker and they actually point on the board where it says the word beaker. And then I want you to pour the, right? And so as they're saying pour the acid in, they're actually doing it. That is contextualized. And so if I'm a student in that class, if the instructor is giving those instructions in Spanish, I am far more likely to understand, because even if I haven't learned all those words in Spanish yet, I have other ways to pick up the meaning, which, by the way, also means I'll add meaning to that vocabulary. So I'll actually come out the other end, not just understanding, but understanding more English. So what I'm trying to say here is that I actually think that science could be the most contextualized discipline that we teach our students, because we're often using tools, we're often carrying out actions that we can act out for them, that we can point at, show pictures, etc. And yet we often reduce the context. We don't give those kind of lifelines to students to understand. So that is a problem around language that's really directly connected to teaching choices. And so we'll come back around to that when we talk about pedagogy. But just to make sure everyone's clear, the first thing that we talked about around the language of science that's difficult is around vocabulary issues. And we talked about how students encounter the most vocabulary they will encounter on any new page in any discipline in science. Many of those vocabulary, not as many as math, but many of those vocabulary items already have a meaning attached for the students, and that meaning is that everyday meaning, that BICS meaning. And also, any tools that you've put in front of students so that they can understand a new vocabulary item will often be defined in terms of other vocabulary they don't know yet. So it kind of forms, in my words, a rat's nest of kind of density. And so those are all vocabulary issues. And then we looked at grammar issues. We looked at the fact that there are a lot of adjective clauses, reduced adjective clauses, complex noun phrases, nominalizations, and the use of passive voice. So lots and lots of issues there. And then even forming the plural is really difficult as well in science, because we draw upon so many Latin words and we follow the the pattern of morphology of how you form plurals, which is not as simple as just adding an S. And then the final thing that I talked about is that often when the language of science is put in front of students, it's completely decontextualized. And even if there are images in their textbook, there's no guarantee that those images are going to directly support the understanding that the students have from the words. So often images do not support. And often when instructors are telling students, teaching concepts or telling students what they're going to do in an experiment, they don't use that additional context as well. Okay? So hopefully that's not a bummer. Hopefully that empowers you to now recognize all the different ways that you can be aware of the language of science and support your students. Okay, so there's some textbook readings waiting for you to carry out, and then there's a little bit of work before you get to the discussion. Okay, I'll see you there.